Kurt J. Lesker, the manual thermal evaporator system. This system is equipped with a cryo pump for generating high vacuum and a mechanical pump for the roughing vacuum. It's a totally manual system, including there's a crystal monitor in the machine. So the bell jar is connected to the cryo pump and the mechanical pump, and the plumbing details are included in the user's manual. There's a vent valve, and the chamber could be vented with dry nitrogen. It's a simple system with a granular Phillips 307 vacuum indication and control of the sequence. All the vacuum valves for the sequencing of the high vacuum in the chamber are controlled by a Omron PLC, and the PLC is controlled using these switches here. These two buttons, the green button is for roughing the chamber, and the red one is for closing the chamber rough valve. And this switch, toggle switch here, is chamber vent, and this switch is for operating the shutter. The shutter will prevent the material reaching the sample. This is directly on the heater filaments, and this switch is here for the cryo rough, which is at the time of initial startup before turning on the cryo pump and cryo compressor. We have to rough the cryo, and in order to do that, this switch should be turned on. And there is an indication for the gate valve. Green light indicates the gate valve is open, and the gate valve can be turned on only when this toggle switch is in on position. You can turn it off and the gate valve is closed, and turn it on, the gate valve will open. These on and off indications are coming from the gate valve itself, where there are opto sensors to sense whether the gate valve is open or closed. The gate valve cannot be opened unless the chamber roughing vacuum is below 20 millitorr. So the gate valve opening is interlocked to the chamber rough, and the ion gauge here, this is the one that is connected to the chamber, which indicates about 5 into 10 to the minus 7 torr now. And this ion gauge signal, when the ion gauge is on, only then the evaporator can be turned on. This controller is the evaporator control, and right now the power to the evaporator is on. And to turn on the heaters, first turn the controller knob counterclockwise all the way to 0, and when we toggle this switch, the output is enabled. There is a selector switch here for selecting 2 filaments for evaporating the material. Right now it is selected on the second one. The chamber, which is a metallic chamber, has a small window here to enable to see when the heater is on, and it has a small shield here. Now I'm going to turn on the evaporator and increase the voltage to the heater filament. The mode selector switch should be in local, and once it increase the voltage slowly, once it is up, you can see through the window there's a glow here which indicates the filament is on and the material is being deposited. I have already put aluminum in the heater elements and the samples are loaded in the chamber. And right now the crystal monitor is indicating that the evaporation is happening. You can see the thickness value increasing. It was pre-deposited up to 60 angstroms. The roughing pump is connected to the chamber and the cryo roughing, and there are valves to turn on the cryo pump roughing here, and that valve is for chamber roughing. And during cryo regeneration, there is a valve here which needs to be opened and connect nitrogen to this, and this is the nitrogen heater, and once you connect this to 110 volts, the nitrogen can be pumped into the cryo pump area warm and hot so that all the top moisture and other gases can be exhausted to the vacuum pump. So during regeneration, manually this valve should be open while nitrogen is being used to purge the cryo, and close the valve and turn on the cryo roughing valve so that the cryo pump will be pumped down to the base pressure of the cryo pump. Now, this sensor will not be included with the machine. This is for just monitoring in-house here at Bit Service. The cryo compressor is right now hooked up to the cryo pump, and the cryo compressor requires single phase power supply. (208 volts), and this is the power to the cold head, and the compressor during operation should be indicating about 275 psi pressure, but while it is off, the static pressure should be 250 psi. If the pressure is low, after connecting the helium lines, pure helium should be connected to this input port, and this valve should be open to increase the helium pressure while watching it on the gauge. Care should be taken so that ambient air will not enter the cryocompressor. This system is also connected with water lines from a in-house chiller here. The water lines are only for the crystal monitor. These are the two water inlet and outlets. And this is the compressed air connection. And there is a vent line which can be connected to dry nitrogen. The roughing pump power is also single phase 208 volts. The main system requires 110 to 115 volts at about 20 amps. All the control modules on the main system are 110 volts. So now there's a material that is deposited about 140 kilo angstroms, 0.141 kilo angstroms. So I'm going to turn off the evaporator power and turn off the ion gauge before I close the gate valve. And once the gate valve is closed, and wait for a couple of minutes before I vent the chamber and lift it up. After closing the gate valve, I give a couple of minutes to cool down the evaporator filaments, and I turn on the vent valve. Now the chamber rough vacuum level starts to rise. Right now I'm venting it to atmospheric air. On normal operation, we can connect nitrogen and vent it to nitrogen as well. So this controller is for controlling the hoist, and the hoist motor is attached to this. Pressing the up button will lift the chamber up. So right now we have vented the chamber, and I'm lifting the chamber to, for normal operation, only this front port can be opened in order to add more material if necessary. But to access the chamber, it is always safe to lift the whole jar. There you go. Now there is a limit switch. The chamber cannot be lifted beyond this much height, and pressing the down button will lower the bell jar. So once the bell jar reaches that, so this arm can be lifted and the chamber can be rotated in order to move it away from the area, in order to clean the chamber area. This is filament number 1 and filament number 2. So this is the shutter arm which will be included. So this is the shutter which operates with the front panel switch. So this is a handmade sample holder. This sample holder is right now fixed to the top of the chamber through the clamping mechanism. The electrode can be lowered and raised, and these brackets here are holding samples, and So if by letting the amount to the aluminum material to evaporate sufficiently, these samples can be deposited. And currently the samples cannot be rotated. For precision applications, additional sample rotating assemblies can be purchased from Lesker company.